Hello and welcome to this new FortiSOAR video. In today's scenario, we'll see a phishing incident management. The scenario has three use cases. So a false positive, a full automation of an incident management, but then the most important is a management of a phishing email. The email is received from the internet, from an outside source. It reaches the mailbox of the recipient. The recipient have a look at it, suspects it to be malicious, and then forwards it to the SOC team which will be ingested then via FortiSOAR. FortiSOAR parses the email, extracts the different indicators, and then uses various techniques to identify whether this is a malicious email or not. If the email turns out to be malicious, an incident response is performed via FortiSOAR. So the email sender is blocked on FortiMail. The malicious content, the malicious email itself, is deleted from the mailbox of the recipient or recipients, if there are many. And then we perform threat hunting to identify whether any of the indicators extracted from this malicious email has been found on FortiSIM. If we have a match, this means that one of multiple machines have been infected, and then we perform a quarantine of these machines until these machines are recovered. And at the end, we generate a report, and then we have a look at the dashboard. And now, without further ado, let's have a look at the web interface of FortiSOAR. All right, the solution pack is available on the Content Hub. So it's the Phishing Incident Management solution pack. You need to install it. Well, it's already installed here. And then when you go to the simulation, you'll be able to find it right here. So you have the solution pack and its documentation right here. And then you can reset and start the scenario from here, or we can do it from the alert module itself. So we can start with the first use case, or the first alert. This alert is an email received by a user and then reported to FortiSOAR, as you can see here. So it received by A. Smith. This is what the reporter said. So kindly review the attached email. It looks suspicious. We have a look here. FortiSOAR automatically parses all the fields and recreates the email itself, so we can see the content of that received email. The source from home, well, this is obviously, so it's an internal email. We have the header of the email right here, and then we have all the extracted indicators from this email. In this case, we have two emails, but both of them are internal. Especially the tier 1 analysts, junior analysts, could use the comment section, where it's a communication space between the different analysts involved in the case management, and also it's a mean for the various automation workflows or playbooks to communicate as well with the analyst. Here we have it's a sort of workbook or a guide to help the analyst perform the investigation. So here we have the first step is to set the status of the ticket to investigating. So the SLA will be calculated, as you can see here, the acknowledgement SLA. And we have a playbook, the phishing alert management and investigation playbook, which will help us to perform the triage. While performing the triage, we can check the what the workflow is about. And here, as you can see, there's a bit of configuration. So basically to define a number of variables that we need, or the playbook needs in the analysis. We determine whether the email has been forwarded inline or as an attachment. As you know, if it has been forwarded inline, the header will be lost. So we basically notify the user to resend it as an attachment, so the analysis could be performed. Then we wait a little bit for the indicators to be extracted and rated. And once this is done, we check whether any of the indicators are malicious. So if they are malicious, we have this path. Otherwise, which is the current case, The email is an internal email. As you can see here, the severity has been set to minimal. And then what we do here, we update the severity, which has been done already. We wait a little bit for the SLAs to be computed, and then we update the alert status. So here you will see the status updated to closed, because this is a false positive, and the playbook has even left a closure note why this alert has been closed. This would be very helpful for the analyst, because they will not have to spend any time on this. The triage process would identify false positives and close these alerts automatically if of course the analysts choose to go for a fully automated approach. Here we have a summary of the alert. So we can see here it's an internal email. We see the sender, where it came from. We have even the technique description that we get through the integration with the MITRE framework, and then we see all the reporter and then the different recipients of this email. And now let's jump to the other use case. That's number 2. The alert is created, and then we can follow the same logic here. So basically we set the status to investigate, the SLA will be calculated, and then we run the triage or the phishing alert enrichment and investigation. It's basically triage, and it will perform the same thing, except this time we should see a different set of indicators. As you can see here, that's a different email, and it's very much a malicious email. So we have a URL, we have an attachment with the email. As you can see here, it's a Word attachment. The indicators are automatically extracted and rated, so we can check here what's the reputation of each indicator. The playbook has automatically identified that this is a true positive, and then it has closed this tier 1 ticket and escalated it to tier 2, and we can see this right here. So the ticket is closed, and then it has been escalated to a tier 2, and it's being processed or investigated as ticket or incident number 55. This all the related objects to this alert will be found in the correlation tab. So we have 4 users, and the users have been extracted and enriched from Active Directory. We have the incident itself. We have the correlation with the MITRE framework, so we have which technique or sub-technique in this case associated with this ticket, and then so is the case with all the other objects which could be associated with this ticket. So let's open now the incident. And here we have, so it's the same logic. We have the incident body itself with the different fields, different attributes of this incident. And then we have on the right side the workspace where we have the comment section, which in this case include a workbook. Right, so let's set the status to in progress. As you can see here, the SLA, the acknowledgement SLA will be calculated just like what happens in the tier 1. And then we will set the phase to confirmation, because we want to make sure that this is a malicious content before we perform the incident response. So here, according to the guide, we should check out the indicators. So we have the indicators right here. Obviously here 4 of them are either malicious or suspicious, so it's very likely a malicious email. But then we can check as well the attachment. So in this case, this seems to be a 0-day. It doesn't have any reputation from CTIs, from cyber threat intelligence sources. But then FortiSOAR has the ability to parse binary files. We have over 1500 file type, like PDF, Office, Visio, what have you. FortiSOAR will be able to parse these files, extract the metadata of the file. In this case, it's Microsoft Word file metadata. We can see with which application it has been made, what's the name of the editor or the author, what's the subject which has been used, the email, etc. So this looks very suspicious to start with. At the same time, FortiSOAR has the ability to extract the content of the file. So instead of having the analyst to create a sandbox and then open the file within that sandbox to prevent any infection for his or her machine, FortiSOAR does this safely and converts the content into a safe text that the analyst can read and evaluate. Here, obviously, this is an attempt for a social engineering, so we will set its reputation to malicious, as it should be, because the file is actually malicious. Now, more than extracting the metadata of the file and the content of the file, FortiSOAR also extracts the associated or the indicators found within the file itself. So it parses the file, the binary file, and it extracts all the indicators that are found within this file. Right, so the file is malicious. We have also several other malicious indicators. We have this graphical correlation. This is very helpful, especially for tier 2 analysts, because it allows the analyst to very quickly have a color-coded diagram of the incident. So they would know, for example, that here we have 4 different malicious indicators. We have 1 suspicious. And these are all related to this alert, the suspicious email alert. Right. At this point, we are good to go with the incident response. So we have a playbook to help us to do that. As you see here, all along the investigation, we are doing a semi-automated one, in a sense where it requires some interaction with the analyst. We'll see how in the third use case the whole process will be automated entirely. Right, so let's run the incident response and see what happens. So here you can see that the sender has been blocked on the secure email gateway. In this case, it's FortiMail. We see here as well that the email sender has been notified that the content is, or the email he or she reported is malicious. And then most importantly, the email is deleted from the mailbox via the Microsoft Exchange integration. And so is the case for every single recipient of that email. So Exchange obviously has to be configured with impersonation privileges in order to connect to mailboxes and then delete the content from there, or delete the email from there. Right, that's not enough, obviously, because any of these recipients could have opened the email and get his or her machine infected. So that's why it's mandatory to perform a threat hunting via our SIM, in this case FortiSIM, in order to make sure that none of the machines have been infected. So we have a playbook which would help us to do that. It's the hunt indicators on FortiSIM, and the way it works is basically just to take all the indicators and see whether it has been seen anywhere in the environment. If there is a match, the TLP field of the indicator will be set to red because it has been seen within the environment, and then the machine on which the indicator has been seen. So this means that this machine, so 323, has accessed this URL. So there's a good chance that the machine has been infected. The logical thing to do. Oh, by the way, before that, FortiSOAR will automatically link that machine or that asset to the ticket. So we can see here the asset, the infected asset, and then all the enrichment data that we got from CMDB. So we have a CMDB integration here where we get extra data or metadata about the asset. So we know which asset is infected. So this is the one, and then the logical thing to do is to quarantine it until the moment it has been completely recovered. And then to make sure that it has been or it will be recovered, there is a task, a manual task created here, which will indicate that some of the SOC staff will have to perform a physical investigation on the machine and then recover it from the infection. Right. At this point, especially after the machine or machine one or multiple machines have been recovered, the ticket is comes to or the investigation comes to an end. So we set the phase to aftermath, and then the status to resolved. So here we have few fields to populate. We have And by this we would have finished our investigation. We have a few options now. So we can run a summary, an incident summary report that will pop up here. And if, for example, the infection is way larger than it is in this case, we can set up a war room where we manage the crisis. So a war room is a tool that FortiSOAR provides in order to manage a large-scale incident and track several activities across multiple departments. Right before that, we can have a look at the dashboards. So we have a dashboard dedicated for this kind of incidents, so phishing incidents. You can see it right here, the phishing incident or phishing case management, where we have generic information like the total alerts. Obviously, all this information is only related or pertinent to the phishing cases or phishing tickets. So we have the total alerts, the ratio of escalation from tier 1 to tier 2, the number of incidents and how many incidents have been resolved so far, mean time to recovery, mean time to acknowledgement. We can see the different executed playbooks during the phishing incident management activities, and so many others relevant information, as you can see here. Probably one of the most important especially for C-level is the amount of time that the analysts are spending at each individual phase of the incident management. So you can see here the mean time for identification, confirmation, containment, eradication, etc. to the aftermath. Right, so until now we have seen how to handle a false positive, how to handle a true positive, but then to show the power of automation specifically, we can check this third use case where the same incident we saw in use case number 2 will be handled in an automated way. So we trigger the incident, and then you will see here that all the playbooks will be triggered in an automated way, and all the processing would happen without the interaction with any analyst. So the incidents are being extracted and rated. The severity has been set to critical, and the alert has been closed and then escalated to a tier 2, as you can see here in the comment section. And then we can check out the incident related to this alert. So here is the incident. We have the different indicators right here. So as you can see here, the threat hunting has been performed as well, in addition to the incident response. So the user blocked on, or the sender blocked on the email gateway, and then the email was removed from all mailboxes. The incident or the threat hunting also has been performed, and then the infected asset quarantined to the point where the ticket itself is closed, as you can see here. So the ticket is set to resolved, and then the phase to aftermath. So it's a fully automated approach, and then we can see here how much time it took. So it took 15 seconds for acknowledgement and 49 seconds for the whole ticket to be processed. By now, the report should have been generated. So we can check in reports history, and here is our incident report. And as you can see, it takes all the relevant fields from the report. So you can see the different indicators and the rating, the incident timeline, and also the description alongside the 5 last different comments on the incident. And by this we come to the end of this video. Hope that was useful for you, and see you on the next one. Goodbye.